Hey Math 1 students, I'm really sorry that I have to miss class today. I'm at a meeting all day. So there's a couple things I want to talk to you about before I dive into the notes that you're going to take. So remember that you needed to complete pages 7 through 9. It was the 4.4 Ready, Set, Go in your packet. You needed to complete that over the weekend. So if you didn't do that, please make sure it's ready by the time I get back to class tomorrow so that I can check that in. This video is going to start on page 10 in your packet, so you're going to take notes along with me from pages 10 to 12-ish. I'm going to skip around and do some problems, and then you guys are going to complete the rest of the problems for homework or for the rest of class. So I'm going to be checking pages 7 through 12 when I am back in class tomorrow. If you've got questions, please send me an email or come into the MRC, or make sure that as soon as we're back in class tomorrow, you ask your questions and get them answered, because you guys have a quiz on the block day this week. So I want to make sure that you are prepared and ready to go. All right, let's go ahead and dive into task 4.5. So we're going to be talking now about solving inequalities. So if you remember, we did a ton about solving equations in Module 4A, and we also did it in Modules 1, 2, and 3, but really the big idea in Module 4A was solving equations. Now we're solving inequalities instead. The nice thing about it is that solving inequalities is the exact same thing as solving equations, with one exception. All right, the only thing you have to remember that is different about solving inequalities, and this is going to be a really big, important idea, okay? The only exception is if you multiply or divide both sides of an inequality by a negative number you must flip the sign. Oops, flip. I can spell, guys, it's fine. This is why I teach math. You must flip the inequality symbol. So take a second, make sure you've got that down. Solving inequalities is the exact same thing as solving equations, except for this big idea. All right, if you multiply or divide both sides of an inequality by a negative number, then you must flip the inequality symbol. Okay, that's why there's some pictures of flip-flops here, because I want you guys to have that in your head. Sometimes we are going to have to flip-flop the inequality. So that's a lot of words, and I want to show you guys just really quickly what I mean by this. So for example, if I have negative 2x is less than 10, we're just going to pretend that that inequality symbol is an equal sign. If we had negative 2x equals 10, how would I solve for x? I need to use the inverse operation, which means I'm going to divide by negative 2 on both sides of my inequality. When I do that, it'll cancel my negative 2 on the left, and I get x. I know that 10 divided by negative 2 is negative 5. And then what I have to remember now is I divided both sides by a negative, which means I'm going to flip my inequality symbol. So instead of being a less than, it is now a greater than symbol. And we're going to kind of explore why in the next problem, and also when I'm back in class, we're going to explore it even more. But I do want to show you guys something really important here. So if you can go off to the side here, I'm going to change this problem just a little bit. I'm going to make it 2x is less than negative 10. So all I did was put the negative number on the other side. So now I'm going to go ahead and solve this inequality. Since this is 2x, I need to use the inverse operation. So I'm going to divide both sides by 2. So I get x, and I've got my negative 5. But now the difference here is that the number that I divided by is a positive 2. So the number I'm dividing on both sides was positive. It means I'm not going to flip my inequality symbol. It's going to stay exactly as it was, because this number here is a positive 2 that I'm dividing by. So that's really the only thing that you have to know about solving inequalities, you guys. It's the exact same as equations, except for this one rule. When you multiply or divide both sides by a negative number, you have to flip the inequality. Did I spell inequality wrong? I did. Oops, inequality. My bad, guys. Again, this is why I teach math. Inequality. Okay, that's much better. Sorry about that. Okay, let's actually look at some examples here then. So this one, we are going to solve and graph. So if we look at this inequality, we can see that there's variables on both sides of the inequality. And so we're going to have to be careful when we're solving this because we need the variables to be together. So I'm actually going to solve this particular one two different ways for you guys. So I'm going to solve it my normal way, which if you solve it like me, then that means you're always getting things on the left side of the inequality, or the left side of the equation, or equal sign, which means I want my variables to be on the left side. So when I look at this, I'm going to subtract x from both sides of the inequality because I need to get them together. So now I have 5 minus 4x, and then I have my 13. Now I subtracted x from both sides. I did not multiply or divide by a negative number. So that means my inequality symbol is exactly the same. It's still a less than or equal to. Now that I have my variables on the left, I want to move all my numbers to the right side. So I'm going to go ahead and subtract 5 from both sides of the inequality so that these 5's cancel each other. Now I have negative 4x, and I've got 13 minus 5, which is 8. I subtracted 5 from both sides, so again, I didn't multiply or divide by a negative, so I'm not going to flip my sign. It's still going to stay as a less than or equal to. Now I'm going to go ahead and divide both sides by negative 4 because that's the inverse of the multiplication. So if I divide by negative 4, I have x, I have my negative 2. Now that I divided both sides there by a negative number, that's the important part there. This is where I'm going to flip my inequality, and it's going to become x is greater than or equal to negative 2. Now we're going to see what would happen if I moved all of my variables to the right side instead. So 5 minus 3x is less than or equal to 13 plus x. So if I'm going to move my variables to the right side, it means I'm going to add 3x to both sides. So I have 5, I have 13 plus 4x, and I didn't multiply or divide by a negative, so I'm going to leave my inequality symbol alone. Now I'm going to move my numbers to the left side, so I'm going to subtract 13. 5 minus 13 is negative 8, so that's less than or equal to 4x. And now I'm going to divide both sides by 4. So I get negative 2, I've got my x. I divided by a positive number, which means my inequality symbol doesn't change. So now I have negative 2 is less than or equal to x. So this is my answer. If we look at these two inequalities, they do actually match. When we flipped this inequality symbol because we divided by a negative, we created the exact same inequality, which we should because we started with the same inequality up at the top. So now we have to actually graph it. So the thing I want you guys to remember it's an open circle if we do a less than or a greater than symbol. It's a closed circle if it's a less than or equal to or a greater than or equal to. Well, I'm going to focus on this one because it's got my x on the left, so for me it's always easier to understand. X is greater than or equal to negative 2. Well, that means then at negative 2 I'm going to have a closed circle because it can actually equal 2. And then I want numbers that are bigger than negative 2, so I'm going to go ahead and shade to the right and draw an arrow that way. If we wanted to graph it from this one, we'd still get the same graph. This one says negative 2 is less than or equal to x. What that means then is negative 2 must be the smallest number that works. So negative 2 is the smallest because all these other ones that we shaded were bigger. So we can graph it from either one. This note down here is for when we're graphing. So I think what we were going to say here was that if the variable's on the left, it's easier to graph. But you don't even have to write that down because you guys have actually been doing a really good job with graphing the correct direction. All right, so let's go to page 11 and let's just try a couple of solving inequalities, and then you guys are going to do some for the rest of class. All right, let's see. Solving this first inequality. Well, solving means we're trying to get the variable by itself, right? So if this is the variable that I want to get by itself, right now it says x minus 5. That means I need to use the inverse operation. So I'm going to go ahead and add 5 to both sides. When I do that, I have x, I have 2, and I didn't multiply or divide by a negative number, so my inequality symbol stays the same. I get x is greater than 2. And that's it. You're just using inverse operations exactly like we did with equations. For example 2, find that variable. It's right here. We're trying to get the m by itself. Right now it says m plus 2. So we can subtract 2 from both sides. Negative 1 minus 2 gives us negative 3. We've got the m. We didn't multiply or divide by a negative, which means our inequality symbol stays the same. So we have negative 3 is less than or equal to m. Now some students that prefer to have the variable on the left might look at this and flip the whole thing before they solve. So some students will do it as m plus 2 is greater than or equal to negative 1. So you flip the entire thing. Remember, it's that pancake flip that I talked about in class. If you change the sides, then you have to change the sign as well. So now when I subtract 2 from both sides, I get m is greater than or equal to negative 3. These are the exact same inequality, so you can write either one. Since we don't have to graph it, we don't really need to worry about the variable being on the left, but it's totally up to you. All right, take a look at number 3 then. So for number 3, we've got negative 4x is less than or equal to 8. If I divide both sides by negative 4, I'm dividing by a negative number, which means I need to remember to flip my inequality symbol. It's now going to be a greater than or equal to negative 2. Again, the only reason it flipped is because I divided by a negative 4. All right, let's see. Let's go ahead and jump to, or actually let's do number 4. This says x over negative 3 is greater than 2. That over tells us we're dividing, which means to multiply by negative 3 on both sides, because that's the inverse of that division. So we get x, we've got a negative 6, and here we multiplied by a negative number, which means we need to flip the sign. So it becomes a less than symbol instead. So we get x is less than negative 6. Number 5 should be pretty straightforward for you guys. Number 6, you see some parentheses, so you're going to need to think about what happens when we have parentheses and how we can get rid of them in order to solve. Let's see. Number 8 is similar to the one I already did. So maybe let's jump to, so if you guys can go to page 12 with me, and we can do one of these ones that just looks a little bit more complicated. So how about, let's do number 10. I think number 10 will be a good one. Yeah. Okay, so let's go ahead and add 7 to both sides, because it says 2x over 3 minus 7. Well, the last thing we did was subtract 7. So the first thing we have to do to solve it is to add 7. So we get 2x over 3 is greater than or equal to negative 5 plus 7 is going to give us 2. Now it says 2x over 3. Well, then that means I can multiply by 3 to get rid of the fraction. So I get 2x is greater than or equal to 6. And now I can just divide by 2 and get x is greater than or equal to 3. I didn't do any multiplying or dividing by negative numbers. I didn't flip-flop the inequalities at all, and so I don't flip-flop my symbols at all either. Okay, I'm really sorry. I want to go back and do one more example. I should have done number 5. So can you guys go back to page 11 and look at number 5? there's my inequality symbol, right? I have 3x plus 7. So I'm going to go ahead and subtract 7 from both sides. I get 3x is less than negative 5 minus 7 is negative 12. And now I'm going to go ahead and divide both sides by 3. So I get x, I get negative 4. And the thing you have to be careful about that students always want to do is now they want to flip the inequality symbol. But if you look at the number that we actually divided by, we divided by a positive 3, which does not flip our inequality symbol. So this is going to stay as a less than symbol. Okay, I know I kind of jumped around a little bit. Sorry about that. I want you guys to take the rest of class time to try numbers 6, 7, 8, 9, and 11. There's an answer key with the sub and with Miss K, so they can check your answers. They can kind of walk you through some things if you're struggling. And then your homework is if you didn't finish the 4-4 Ready, Set, Go over the weekend, you got to look at that. And then all of the problems on pages 10 through 12 should be completed. So if you finish that, you can just go ahead and relax for the last few minutes of class. And then I will be checking in pages 7 through 12 tomorrow when I see you. All right, good luck.